Okay, this is Trig Unit 1. We're moving on to Topic 6. We're really focused on the unit circle. So if you had any issues with that worksheet over the weekend, hopefully this video will help clear anything up. Now, the deal with the unit circle is the unit circle deals with a radius of 1. So we're talking about a unit circle that has a radius of 1. So this radius right here, no matter where you look at it, the radius all the way around the circle at any position, the radius would be 1. Okay, so this is your chance to get out the circle I gave you guys, the one side that we do some notes on, and the other side I told you to leave open. We're going to make that the unit circle. Okay, in order for us to understand the unit circle, we have to understand a couple of the key angles that we really are interested in. That's 30 degrees, 60 degrees, and 45 degrees. Okay, so we could work on the 30 and the 60 together because we can make a triangle here. And we could, well, that's kind of, I guess it's an okay triangle, but I'm going to make it look a little bit more like a 30, 60, 90 triangle. So here we go. Okay, so we have this 30-degree angle here, and the radius, if this is a circle that gets swung around here, okay, the radius is the hypotenuse. The hypotenuse and the radius are actually acting like the same value, and that would be 1. So let's find the other two sides of this if the radius is 1. And the hypotenuse being 1, of course. So now remember, in our traditional model of the 30, 60, 90 triangle, the hypotenuse is 2x. And if the hypotenuse is 2x, then x would therefore be, so that means the 2x is the 1. That means the x would be the 1/2. Okay? So that means that the side across from the 30 degrees, the height of this triangle would be 1/2. The base down here, the adjacent side, would be radical 3 over 2, because it would be the x value 1/2 times radical 3. So radical 3 over 2. Alright, so hopefully that makes sense. Now, this is obviously the 60-degree angle, so we could draw a picture of that one as well, thinking more of the actual setup here. Because remember, the setup here is, let me kind of draw it in the corner here. Here's the x and y axis, and this is the value, coming out. So think of standard position, I guess. Okay, so let's draw one here as well. So here's the xy axis, and in standard position, if I make this the 60-degree angle, oh boy, that is really bad. Anyway, if I make this the 60-degree angle right here, then that means the hypotenuse is still 1. That's the radius. So again, here's the 30. Across from the 30 would be the 1/2, and the height would be the radical 3 over 2. So it's basically the same triangle. It's just kind of flipped. I know that my pictures don't do a lot of justice there, but it's the same triangle. It's just flipped around. So we have the 30 down here as the angle stemming from the initial side versus the 60 stemming from the initial side. And that just changes because across from the 60 is the radical 3 over 2, no matter which way you look at it. Okay? So these are some important values. So 1/2 radical 3 over 2 are some important values to think about. The other triangle we want to talk about is the 45, 45, 90 triangle. So that would be 45. This would also be 45, and here's the 90. And again, this is the center, and we're rotating this, creating our circle here. Okay, so again, the hypotenuse or the radius is 1. Right there. So if that's 1, how do we find the other sides? Well, we know traditionally that this hypotenuse is x radical 2, and that needs to equal 1. So I got to solve for x here, and I get that x is 1 over radical 2, which I don't like. So I'm going to multiply by 1, which is radical 2 over radical 2, and I get that x equals radical 2 over 2. So that means this side over here, the opposite side, is radical 2 over 2. The adjacent side is also radical 2 over 2. So when we're dealing with the unit circle, we're dealing with a radius of 1. 45 degrees, radical 2 over 2. So now let's actually take a look at the unit circle here. Okay, now what we want to realize here is that this unit circle has a radius of 1. So that means this point right here would be 1, 0. This point all the way across here would have to be 0, -1. Okay, so this is quadrant 2, quadrant 1, quadrant 3, quadrant 4. This point up here would be 0, 1. Wow, I messed this up. I apologize. Crap. This right here would be -1, 0. I apologize for that. I was thinking ahead. Anyway, this point down here would be the 0, -1. Okay, so those are obviously our quadrantal values, okay? So that's 90 degrees, 180 degrees, 270 degrees, and back to 360 full degrees around a circle. So let's first draw in here the 45 degree right here. So if we make our 45 degree mark right here, or you might want to put that mark inside, whatever, I don't care. But at 45 degrees, we have to think about the point x comma y. So now if we think about this value right here, this length right here, that's the hypotenuse, that's 1, right? And then we think about the triangle that would be made. The height of that triangle would be my y value, and the base, or the adjacent side, or the base of that triangle would be the x value. And we just got done showing you that in a 45 degree triangle with the hypotenuse of 1, the height, or the both legs, are both radical 2 over 2. So we know that both the x and the y are radical 2 over 2. Okay. We could also draw in the 30 degrees right here. Okay. Note that 30 degrees is not perfectly in between 45 and 0, obviously. Okay, it's closer to the 45. Anyway, so if we would think about drawing that triangle here, so think about drawing that triangle, that would be a 30 degree triangle, hypotenuse 1. And we just got done saying that if this is the 30 degrees right here, across from the 30 degrees would be the y value, and across from the 30 degrees would be 1/2. Okay, and then the base of the triangle, or the adjacent side to the 30 degrees, or across from the 60, would be radical 3 over 2. Then we could talk about the 60 degree angle right here. Okay, so if we think about the triangle that would be drawn, it'd be the exact same triangle. It'd still be a 30, 60, 90 triangle, but it's just flipped around. It would also have a hypotenuse of 1, or the radius of 1. And across, let's see here, this would be 60. Across from the 60 degrees would be the height, and that would be radical 3 over 2. And the adjacent side, across from the 30, would be the 1/2. So I know I'm kind of marking this up. I really want you guys on your unit circle to have 30, 45, 60, and have these points labeled. But I really want to emphasize why this is. Let me draw this actual 60 degree triangle right here. Okay, so there would actually be that 30, 60. Okay, I'm sorry for my drawing skills here. So this would be the 60 degrees. This would obviously be the 30. So again, across from the 30 would be the 1/2. That would be the x value. And across from the 60 would be the radical 3 over 2, the y value. So hopefully you understand where that point comes from. But of course, technically, let's be honest here, it's the x value divided by the radius. Well, that's where we get radical 3 over 2 divided by 1. That's why with the radius of 1, we don't have to worry about that dividing by the radius, because the radius is 1, so it makes it easy. So hopefully that makes sense here. I'm going to quickly show you this other triangle as well. So like if you think about this 45 degree triangle right here. Apologize for my wavy lines. Again, in this 45, the hypotenuse is 1. This side across, the height of the triangle would be radical 3 over 2, radical 2 over 2. And the base down here would also be radical 2 over 2. So the y coordinate would be radical 2 over 2, and so would the x coordinate. Now, what I want to show you guys is how we could build the rest of the unit circle from this, okay? So let's think about the angle that would be directly in between 90 and 180 degrees. Again, this is 180 degrees. At the very top here would be 90 degrees. So directly in between here, well, what angle is directly in between 90 and 180? Well, it would be 90 plus 45. It would be 135 degrees. So this angle right here would be 135 degrees. Now this angle right here is 135 degrees all the way from initial side to terminal side. But think about it, this angle that's left over would be 45 degrees. So if we would draw that triangle, we would essentially have another 45 degree triangle. And in that triangle, the height is radical 2 over 2, and the base is radical 2 over 2. Now you just got to be careful, because we're in quadrant 2. The base, or the x value, would be negative radical 2 over 2, and the y value would be positive radical 2 over 2. Okay? Now we could do the same thing if we come over here, right? So this would be 120 degrees. Now, why is 120 degrees important? Well, if you think, I know I'm getting a lot of mess here, but hopefully you're following me. This would be the 120 degrees, which would mean this inside angle right here would be the 60 degrees. So if I make a triangle, and again, I just want you to label the outside there. You don't have to draw these triangles inside. But we would have a 60, 30, 90 degree triangle. And across from the 30, the base right here, the x value would be the 1/2. Okay, but we're in quadrant 2, so it would have to be negative 1/2. And the height of the triangle would be across from the 60, which is the radical 3 over 2. Okay, so hopefully that makes sense. And then we could also come over here and talk about 150 degrees. Why are we going to talk about 150 degrees? Because if I would draw 150 degrees, the leftover angle that would create my triangle would be 30 degrees. And again, I know it's getting messy. I apologize, but hopefully you're starting to see this. So once again, if I draw 150 degrees, I'm essentially drawing another 30, 60, 90 triangle. So across from the 30 would be the y value, which would be the 1/2, and the base would be across from the 60, which would be the negative radical 3 over 2. Again, why is it negative? That's because it's drawn into the second quadrant there. Now, notice that 150 is directly across from 30. So look at the 2 points. 150 directly across to 30. It's the same point. Radical 3 over 2 for the x and 1/2 for the y. It's just a matter of the x over here for 150 had to be negative. Okay? And this same process can get created down into here as well. This angle down here would be 180 plus 45 degrees, or 225 degrees. But notice, if this is 180 and I go another 45, I get the 225. So yet again, I have a 45, 45, 90 triangle, where the height of the triangle is radical 2 over 2, and so is the base. But you got to be careful, because in this particular quadrant, both x and y are both negative. Okay, so I know that I've made a nice mess of this triangle here, but I have a nice, perfect, beautiful one to show you here. Look how nice this is, right? Look, my handwriting was perfect on this. Now, ignore these pi stuff here. So I'm going to kind of scribble these out. That is for later use. We'll worry about that a little bit later. Don't quite worry about that yet. I'll kind of keep scribbling those out. Those are a different way of measuring angles, and we will eventually get to that. Just kind of want you to ignore that. So here's the deal. We start at 0 degrees, 1, 0, right? Then we go to 30 degrees. That's radical 3 over 2, 1/2. 45 degrees, 60 degrees, and so forth. Now, this is the first quadrant. Every single quadrant is modeled from that. So if we go 30 straight over to 150, notice it's the exact same point, but the x had to be negative. Come straight down to 210. Now, if I would draw 210 here, I'd come all the way. So that'd be 180 plus, 30, making it very similar to a 30, or not very similar, make it a 30, 60, 90 triangle, which is why the x and y coordinates look so familiar, radical 3 over 2 and 1/2. But because we're in quadrant 3, both guys are negative. So this is what I want you to draw on there. This is the unit circle. And it's all based on our special triangles. There's nothing new. I'm not trying to introduce some new crazy thing to you. It's all based on our special triangles. So even when we come all the way over here to 315 degrees, well, guess what? If this is 315 degrees, guess what's left over? 360 minus 315? Oh, what do you know? 45 degrees. So that's why at 315 degrees, I see these values that are coming from a 45 degree triangle, with the hypotenuse, or the radius, of course, being 1, making the sides both radical 2 over 2 and radical 2 over 2, but the y had to be negative down in this quadrant, okay? So this should hopefully all make sense. And then if we go back and start thinking about sine of theta now, cosine of theta, and tangent of theta, it should make so much more sense when we're in the unit circle. Because remember, sine is when you draw one of these triangles where we have y is the height, x is the adjacent side, and r is the radius, or the hypotenuse. When we think about, wait a minute, now we're talking about a radius of 1, so sine is y over 1, or just y in the unit circle. Cosine is x over 1, or just x in the unit circle. Tangent would still be y divided by x. So they're cousins, so cosecant of theta would be the reciprocal of y, or 1 over y. But instead of r over y, since r is 1, it's 1 over y. Secant of theta would be 1 over x, the reciprocal, and cotangent of theta would be x over y, the reciprocal of tangent. So hopefully that makes a lot of sense, I guess. So if I said to you, hey, find sine of 30 degrees, you would just look at 30 degrees and tell me the y-coordinate, which would be 1/2. And I'll tell you what, guys, you need to be able to, at this point, completely understand that. I mean, if I draw a 30-degree triangle right here, and I'm telling you that the hypotenuse is 1, then that means the side across from 30 degrees would be the 1/2, which means sine would be opposite over hypotenuse, 1/2. 1/2 over 1, 1/2. And I could say, what about cosine of 150 degrees? Well, you find 150 degrees, and you're looking for cosine as the x-coordinate, and that would be negative radical 3 over 2. Now, why do I need the negative there? Well, because it's signifying that in this unit circle where you're going in different quadrants, 150 degrees is in quadrant 2, where x's are negative. What about tangent of, say, 40, not 40, let me choose one that's weird. How about 315 degrees? Well, I'm going to find 315 degrees. Tangent is y divided by x. Look at this, y divided by x. I take negative radical 2 over 2 divided by radical 2 over 2. I get negative 1 because I get the same value. Y and x are the same except for y is negative. Oh boy, what just happened there? I have no idea. Something got moved around. There we are, here we are, here we are, here we are. So anyway, hopefully that makes a lot of sense to you. I really do. It should. That's the importance of using the unit circles, that you're assuming, or not assuming, you know that the radius is 1. Alright, so there's a couple other problems that are in our homework that I really wanted to make sure you know how to do. Let's say that I told you that sine of theta was 5/8. And I told you that tangent of theta is less than 0. Okay, now what am I trying to tell you here? Well, first off, let's think about our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. If sine is 5/8, that means sine is a positive value. Sine is positive in quadrant 1 or quadrant 2 because sine is directly related to y, and y is positive in quadrant 1 or quadrant 2. Now, tangent being negative, tangent is a combination of y divided by x. So for tangent to be negative, I must be in quadrant 2, because in quadrant 2, y's are positive, which I knew because sine was positive. And the x has to be negative because y divided by x would have to be negative. And if I was in quadrant 1, they'd both be positive. Y and x would both be positive, and tangent would therefore be positive. But I'm clearly telling you that tangent's negative. So this kind of information is directing you to what quadrant you're in. Once I know what quadrant I'm in, I can think about positive and negative. So let me draw a picture of this in the proper angle here. So here's theta right here. And I know that sine is opposite 5 over hypotenuse 8. So the only thing I got to find is the adjacent side. So I know that 8 squared equals 5 squared plus a squared. So that's going to be 64 minus 25 is 39. So I get that a squared is 39, square root. I got to take the square root of 39. And unfortunately, I don't think that could be reduced. 39 is not divisible by 9, it's not divisible by 4, it's not divisible by 16, so I think I'm stuck here with this adjacent side being the square root of 39. Now, when it comes time for me to figure all the values out, I got my triangle. So I already know sine. Let's find cosine real quick. Cosine is going to be, here's my angle, adjacent radical 39 over hypotenuse 8. Done. Look how easy that was. But wait a minute, I'm in quadrant 2 because of my information that was given. So that means cosines in quadrant 2 are negative. How about tangent of theta? Tangent is opposite. Nope, I got to do some dirty work here. Opposite 5 divided by adjacent, the square root of 39. I'm going to multiply by the square root of 39. And I get that tangent is 5 radical 39 divided by 39. But in the second quadrant, and I also was given the fact that tangent was negative, I need to make sure tangent's negative. Now for their cousins here, let me do this in a different color. The cousin of, or the reciprocal of sine is cosecant. So cosecant would be an easy 8/5. Let's see here, secant would be, oh, got to do some dirty work. It'd be 8 over the square root of 39, and just make sure you keep it negative as well. So I'm going to multiply by 1, and I get negative 8 radical 39 over 39. And cotangent is, I could take sine or tangent and flip it to find the reciprocal. But you know what? I'm going to go back to the triangle and think. Cotangent is adjacent divided by opposite. So it'd be radical 39 divided by 5. But don't forget, it is negative, because if tangent's negative, so is cotangent. If cosine's negative, so is secant. If sine's positive, so is cosecant, because they're just the reciprocals of each other. And when you take the reciprocal, you don't change anybody's sign. So the idea is I could give you a trig function like 5/8 for sine, and you could draw the triangle from it, use the given information to figure out what quadrant you're in, because at the end of the day, the quadrant you're in determines who needs to be negative and who needs to be positive. All right, so hopefully that all makes sense to you guys. Hopefully you could use all that information to fill in your unit circle. So if you need to fill it in, go ahead and hit pause on this slide right here. Fill in all the way around. You don't have to draw all of the lines and stuff like that in the middle, but I do want to see all the angles that I have marked there, and I want to see all the points that I've marked there. And hopefully that all makes sense to you. Hopefully you were able to build all that. I'm sorry for this messy drawing, but I was trying to explain it all to you. But it all comes back to the special triangles, 30, 60, 45. Those special triangles that can be drawn. And when the hypotenuse is 1, you learn an awful lot about the x values and the y values that correspond to the opposite and the adjacent. The opposite is always the y, the adjacent is always the x, and that is why at the end of the day, sine is y, that's the opposite, cosine is x, that's the adjacent, tangent is the opposite over the adjacent, so y over x. Alright guys, hopefully that made sense. Hopefully you can use that to build your unit circle and finish the problems in that packet. I know there's some tricky ones, but just take your time with them. Hope you can figure them out. The answers to those packet problems are online in the Honors Pre-Calc documents, so please check that out. So when we come back in on Monday, we could really do a nice job going over all that. And Jared, don't forget to wear your glasses so you could see what the heck's on the board. Peace out.